look at solving these identities here. Now remember, yes, you've got to feel the pain. You just can't sit there. You've got to try something. Try something. The biggest thing, if you have no idea what to do, try changing everything into sine and cosines. If you see a trig function squared with a 1, immediately look at those Pythagorean identities. Those are probably two of the best ways to get started, but you've got to try something. Otherwise, you'll never be able to get it. Again, it's going to take practice in recognizing the patterns. The quicker you get to know the blue sheet, the easier and quicker these will become instead of having to constantly look at the blue sheet and figure out what substitutions to do when. All right, so let's take a look at, on page 6, problem number 6A. So first of all, as I mentioned, when you see a trig function to the second power with a 1, try and use your Pythagorean identities. So again, my first step, obviously, pick the side that's the most complicated. So I'm going to pick the side that is on the right that I highlighted. So tangent squared x plus 1 by your Pythagorean identity is secant squared. All right? Any questions on that first step that I did? Remember, as I was checking some of your homework, a lot of you were not putting reasons or justifications next to your steps. You're not going to get credit if I do not see a justification. You've got to write Pythagorean identity. So make sure when you're doing your homework, you are putting your reasons there. Now, the issue with cosine squared x minus 1, that looks like another possible Pythagorean identity. However, what's the matter with this? The signs are incorrect. Remember, for a Pythagorean identity, it has to be a minus cosine squared and a plus 1. So that's where, remember, you can factor out a negative 1. And remember, by factoring out a negative 1, it's going to flip the signs of what's inside the parentheses. All right? Now that you've got the negative cosine squared and a positive 1, now you can do a Pythagorean identity substitution for sine squared. Any questions on the first 3 steps?
Wait, so if you take the negative out of one, you have to take it out of the other two?
No, you only took it out of the 1 term right here.
But did you take it out of the secant because there's a negative?
I just, instead of, remember, it's all multiplication. Instead of having the negative sign here, I just moved it to the front. Always keep an idea or a lookout where you're going. Remember, it's always nice to know what the end is supposed to look like. We know it's supposed to be a tangent. We know tangents are sine over cosine. You've got the sign here. So the question is, there is a way you can change secant into terms of cosine by using your reciprocal identity. So secant squared, remember, is equal to 1 over cosine squared. So by your reciprocal identity. And then when you multiply, you end up with negative sine squared over cosine squared. You're going to multiply. And then by your quotient identity, that's equivalent to negative tangent squared. So any questions on 6A? Remember, there's more than one correct way to get to the end. Your order may be a little different. You may have done something slightly different. It does not mean you are incorrect. All right, there's lots of different possibilities you can come up with. The order may be different than from what I have to what you have. Yeah, Kirsten?
I have an overall question. Can you do more than one thing in one step?
No, you need to break it out. You need to break it out, okay? Now, if you have 2 Pythagorean identities in the same step, then yes, you could do 2, but if they're different reasons, then you got to break it out. Okay. B is, we're going to talk about B with common denominators in a minute. Let's jump down to C. So obviously looking at the left-hand side is more complicated. Remember, pick the more complicated side and stick with that. Again, a 1 and a trig function squared, go to those Pythagorean identities. So that's going to give you a sine squared times your cosecant. That's your Pythagorean identity. Now remember, the relationship between cosecant and sine is that they're reciprocals of one another. So looking at your reciprocal identities, cosecant of x is equal to 1 over sine x. And then when you multiply, remember, you can cross-cancel your common factors. So you can divide a sine x out of a sine squared, and that'll just leave you with a sine x. And if you wrote divide there or cancel, that's fine. Any questions on C? Part D, we did one very similar in your notes last class. Cosine to the 4th minus sine to the 4th. Work with the side that has your higher powers. Remember, cosine to the 4th is a perfect square. So is sine to the fourth. They're separated by a subtraction sign, so you can factor doing a difference of squares. So that breaks up into cosine squared x minus sine squared x, cosine squared x plus sine squared x. Now again, looking inside the parentheses, you have two trig functions squared. Go to your Pythagorean identities and see if you can do a Pythagorean identity substitution. Cosine squared plus sine squared is equal to 1. So you're finished that one. So any questions on D? And then the last two, E and F. Again, in letter E, you've got a Pythagorean identity in secant squared minus 1, which is just tangent squared. So we know tangent is sine over cosine. So if I use my quotient identity, I can rewrite tangent squared as sine squared over cosine squared. Remember, anytime you're seeing tangents mixed in with sines and cosines, try changing the tangent into sine over cosine. And then you can cross cancel that cosine squared. So any questions on E? And letter F was very similar to letter D. Again, factoring that side with those fourth powers. So any questions on that warm-up? All right, let's take a look then.